Hey y'all, we are Memphis Community University and we are back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today we're going to be continuing our derivative topics unit. So these are topics where the questions involve taking a derivative somewhere, and we're going to be doing the most important derivative topic, tangent lines. So tangent lines appear on the AP exam so many times, they just sprinkle it all throughout the exam on free response questions. I've seen it on accumulation free response questions, graph free response questions, area and volume free response questions, differential equation free response questions. If they're not in the free response questions, you can ensure that they're going to be in the multiple choice questions. If you're taking a college calculus exam, I can promise you that they'll appear once, twice, 3 times on college calculus exam. So they're very important. So let's cover them. The great thing is that they're not too difficult. They're the same thing over and over and over again. We've covered them a little bit before. And remember that for tangent lines, the word tangent means that the slope is going to be the derivative. So all we need for the equation of a tangent line, it is a point and a slope where the slope is the derivative. I'm going to repeat this sentence over and over and over and over and over and over and over again throughout this video. What do you need for a tangent line? A point and a slope where the slope is the derivative. How do you find the equation of the tangent line? You first find a point, then you find the slope. And how do you find the slope? Well, you take the derivative and you plug in your x-coordinate. So again, what do you need for a tangent line? Point and slope where slope is the derivative. Point and slope where slope is the derivative. So let's see this in action. So again, we're going to be talking about tangent lines today. All questions involving tangent lines. Let's get started. So first thing I'm going to do is I'm going to draw a picture of a tangent line for you. Just a little bit of review. So let's say this is f of x. I know my function looks so crazy, but this is where my point is going to touch. So this is what is called a tangent line. Let's see if I can make it touch. That looks like it's good enough. This is A, so some coordinate A. And why is it called a tangent line? Well, from Latin, if you know a little bit of Latin, tango, tangere, texi, tectus, those are the principal parts of the verb tango, which means to touch. So why is this line so special? Why is calculus so special? Well, in our Algebra 1 days, we needed 2 points for the equation of a line, but now we only need 1 point because of calculus. Because how do we find the derivative? Well, the slope. Well, the slope is the derivative. Sort of spoiled the fun there. So again, when you want to find your equation of your tangent line, what we're going to do is we're going to find 2 things. We're going to find our point. So we'll just write out the word point. It's going to be a comma f of a. So sometimes they give you the y coordinate. Sometimes they don't give you the y coordinate, but it's going to be pretty easy. They always give you the x coordinate. So just take your x, plug it in, no calculus involved yet because that's for the slope. So what we need is a point, and then the slope is the derivative, so it's going to be f prime of a. So you're going to take the derivative of your function using the main rule, which is quotient rule, product rule, chain rule, power rule, if necessary, and then you just plug in your a. Then the equation, you have many forms of the equation that you can choose. You can choose point slope form, you can choose standard form, you can choose y-intercept form. But I always choose point slope form because it's the easiest one. It's going to be y minus the y coordinate, f of a, equals the slope, which is f prime of a, times x minus the x coordinate. And we were able to squeeze in all of this work. Let's erase some of the function. So this is going to be the tan line, the equation of the tan line. And then there's one notion that we're going to talk about right now is that there's another line that sometimes is definitely much rarer than tangent line, but it's normal line. Normal line is the line that has the same point, but is perpendicular to the tangent line. So it's coming perpendicularly away from the function. This is a right angle. And what I do is when I do the normal line question, so this is the tan line, so this is tan, this is normal line. When I see a normal line question, I just find tangent lines because I just do this tangent line question and then I just switch the slope at the very end because again, this line is perpendicular to the tangent line. So the normal slope's derivative is the opposite reciprocal of f prime of a. We're trying to bring back a little bit of Algebra 1 here. So normal line, we're going to do the tan line, but instead of y minus the y coordinate where the slope is f prime of a, it'll be negative 1 over f prime of a. So we'll do maybe one example of normal line throughout this video. But again, we're going to focus on tangent lines so much because they're so ubiquitous throughout these questions, these calculus exams, and we want to conquer them. For some reason, sometimes my students struggle with tangent line, but it's the same thing every single time. All you need is a point and a slope where the slope is the derivative. So let's see that in action. Let's just do a normal tangent line question. So I'm going to erase this real quick. I'm going to erase this. So first question I'm going to have is, let's say we have f of x is equal to x plus 2 over x. and we are trying to find the equation of the tangent line. So find the equation of the tangent line. Let's write out all these words. At x is equal to 3. So I see this question on an AP exam and I'm like, yes, it's tangent line. And I know what tangent lines are. Tangent lines are the equation of the tangent line requires two things, a point and a slope. So I just like to write the word point. I need a point and I need a slope. So that's going to be m. And I remember that tangent means that the slope is going to be the derivative. So eventually I'm going to try to find f prime of 3. F prime of 3. So to start off with, I like to find the point first because it doesn't require calculus. So it's going to be 3 comma something. Again, they didn't give me the y coordinate, but I'm not going to complain too much because it's pretty easy to find the x coordinate, the y coordinate. From the x coordinate, all you do is you plug in 3 into the function. 3 plus 2 is equal to 5. 5 over 3 is going to be the y coordinate. So again, even if this y coordinate is given, just plug in the x coordinate into the function. And then for the derivative, for the slope, just take the derivative correctly. If you need power rule, if you need chain rule, if you need quotient rule, if you need product rule. So some students know how to take derivatives when the question is literally just take this derivative. But if the question involves a derivative, like this one right here, to find slope, they forget their rules. So this derivative is going to be quotient rule. So what is f prime of x? Well, it's low, x plus 2 times d high. X plus 2 times d high, which is times 1. Low d high minus high, so just minus low. Oh, sorry, I'm not doing this right. Let's try to do quotient rule correctly. Low d high minus high d low over low low. I don't know why I was messing this up. Low is x, d high is 1, so low d high minus high. I promise I know quotient rule. You don't have to test me. Low d high minus high, but I put the high in parentheses. That's important. D low is just another times 1, and then don't forget low low, of course. We're going to plug in 3. Looks like when we plug in 3, we're going to get 3 minus 5 over 9, because 3 squared is 9. Keep in mind that these parentheses were very important, because when I plug in 3 plus 2, 5, I want to do negative the entire thing. And then finally, this slope is minus 4/9. So now we can go for the equation of the tangent line, because we have our slope and our point, where the slope was the derivative. So I always do it in point slope form. It's going to be y minus the y coordinate, 5/3. Point slope form is just slope, basically. Negative 4/9 is going to be the slope, x minus 3. So this is my answer. And we might as well do normal line. So this wasn't the question. I don't know about you, but when I take calculus exams, I answer a question and then I make up my own question after it just to see what I need to know. So let's do normal line now. Normal line, remember, this is the tan line. Normal line is you just take your tangent line and just switch the slope into the opposite reciprocal. So the normal line in this case, normal line would be y minus 5/3, same point. It goes through the same point, it just has a different slope. It's going to be 9/4 instead, because the reciprocal of negative 4/9 is 9/4. And that's all it is, nothing too crazy. Point and slope, where the slope is the derivative. So let's do another one of this level where you find the tangent line and the normal line. So I'm going to erase this now. I'm going to erase this. Let's see. So the hardest part about this is probably just taking the derivative correctly. So we're going to have f of x is equal to e to the 3x plus 2x. And we're going to find the equation of the normal line now. So let's just erase the word tangent and put normal. And then we're going to put 0. So this is going to be our question. So when I see normal line though on the AP exam, what I think is I like tangent lines better because I know what tangent lines are. They're lines that require point and slope, where slope is derivative. So I'm going to sort of cross this word out and I'm going to write the word tangent. And I'm going to find the tangent line instead, just like we did in the previous example. And at the very end, switch the slope and that'll give me the normal line. So how do you do tangent line? Well, you need a point and a slope where the slope is the derivative. So I have my point here. It's going to be 0 comma something. Then my slope is going to be the derivative evaluated at 0. So let's get started. For the point, plugging into that x coordinate to find the y coordinate. When you plug in 0, it will be e to the 0, which is 1. 1 plus 2 times 0, that's 0. So it looks like it's 0 comma 1. Not going to complain about that. Then when you plug in 0 into the derivative, well, you first have to take the derivative. So let me do that for you. And remember, please, just take the derivative correctly, especially with small chain rules. That's where people mess up the most. So f prime of x, the derivative of e to the 3x is not just e to the 3x. there's an inside function of 3x, so you need to multiply by the derivative of 3x, so that's why it's 3 e to the 3x. Then you write plus 2, because the derivative of 2x, of course, is plus 2, and then we can plug in 0. So when we plug in 0, it's going to be 3 times e to the 0 plus 2. E to the 0 is still 1, any finite number to the 0 is 1. So it looks like it's 3 plus 2, which is 5. So now we're ready for the tangent line because we have a point and a slope, where the slope is the derivative. So in this case, the tan line equation is going to be y minus the y coordinate, y minus 1, equals the slope, which is 5 here, 5 times x minus 0. But keep in mind that this actually wasn't the question. We can't just change the questions arbitrarily, unfortunately. Let's actually do normal line. But normal line is just one additional step from the tangent line. So normal line is going to be, all this is going to be the same, except our slope is going to switch to the opposite reciprocal. That's going to be negative 1/5. So it's going to be y minus 1 equals negative 1/5 x minus 0. And that's how you do these basic questions. So after these basic questions, let's do a little bit of a harder challenge. Let's try to do some questions that aren't just point and slope, where slope is derivative. Literally, we might have to set things, random things to be equal to each other and things like that. So let me erase this real quick. So let me erase this guy, erase this guy. So I'm going to do one where it's a little bit harder to take the derivative. So this is my next question. Suppose f of x is equal to y, where y satisfies this equation right here. Let's do minus xy equals x squared. I'm going to put a number here, but I don't know what number I'm going to put yet. And what we're going to try to do is find the equation of the tangent line, of course. So I'm going to abbreviate this as equation of tan line 2f of x. Nice to know what function we're dealing with. In the previous ones, it was always the given. There was no additional function. So it's 2f of x at x is equal to, let's say, we'll give both coordinates actually. Let's say x is equal to 1 and y is equal to 2. Let's see if this works. So looks like we want 1 here, so that's going to be 1 on the side. 4 minus 2, so it looks like we need to add 1 here. And I think that should be good, because you have 1 plus 1 on the side, which is 2. 2 squared is 4, 4 minus 2. So yeah, this is a valid equation. So let's go for this guy now. So again, right when you see equation of the tangent line, even if it's a harder equation, you go for two things. You need a point and a slope, where slope is the derivative. Great news, they gave me both coordinates of the point, so I don't need to do anything. Point 1, 2, how lovely. So now we only have to go for the equation. And to go for the equation, we need the slope, and to go for the slope, you need the derivative. So time to take the derivative, and now this is implicit differentiation, taking the derivative of things with y. Remember that when you do implicit differentiation, anything that has a y needs y prime when you take its derivative, because that's the chain rule. Y is a function of x. And also be careful of the product rule when you're doing implicit differentiation and these constants. So the derivative of y squared isn't just 2y, it's 2y times y prime. Then I need to take the derivative of minus xy, but I'm going to think of this as the product rule, where the first thing is minus x, the second thing is y. So derivative, so it's going to be minus 1, times keep the same, which is 1. Then keep the same, which is minus x. And then finally, the derivative of y isn't just 1, it's y prime. So times y prime. The derivative of the right side is a little bit easier, just going to be 2x plus 0. I'm not going to write the plus 0 because I'm not a plebeian. So this is the derivative. Again, anything that had a y needs y primes, and I also did the product rule. What we did in implicit differentiation questions is that we solved for y prime by bringing everything with a y prime to this side, anything that didn't have a y prime to the other side, and we isolated. But when you have a point, you can just plug in the point into x and y and just solve for your y prime immediately. So that's what I'm going to do, because I like numbers better than variables. So I'm going to plug in 2 for y, 2 times 2. Nothing to plug in for y prime, because that's what I'm solving for. Then looks like it's going to be 2 times 1 times 2, because again, I'm plugging in y. Then when you plug in x, it's just going to be 1, so it's going to be y prime. And then finally, again, plug in 1 for x, so it's going to be 2. Looks like I can solve this real quick. Not going to be too challenging. If I bring the 2 over, it's going to be equal to 4, and then it's going to be 4y prime minus y prime. That's 3y prime. Looks like our answer is y prime equals 3/4, at least our slope. And now that we have the slope, we're happy because we're ready to go for the answer because we have a point and a slope where the slope is the derivative. So I'm going to put the answer in this nice little box here. It's going to be y minus the y coordinate, so it's going to be y minus 2 equals the slope, which is we found to be 3/4, and then it's going to be x minus 1, x minus the x coordinate. And that's all it is. So again, even in these harder questions, it's still the same thing over and over and over and over again. Point and slope, where slope was the derivative, where the derivative in this case required implicit differentiation, which is y primes and potentially product rule. So let's do a few more questions that are a little bit more challenging or a little bit worded funny, and then we'll see the last question will be the most challenging of all, and we'll see why that one is a little bit harder than the rest. So my next question is going to be, given that f of x is equal to x to the 4th minus 6x squared plus 3, find for what x does, let's write the word does correctly, f of x have a horizontal tangent line is going to be this question. Horizontal tangent line. Horizontal tangent line. So this is a little bit confusing. Does, we can write the word does correctly. So this is a little confusing because we have 3 different words here, but I'm not intimidated by these words because I know what I need for a line. For a line, I need point and slope, where slope is, I need a point and a slope. For tangent, that slope means that it's going to be the derivative. That's what we've been talking about. And what does horizontal mean? That means your slope is going to be 0 because you want a horizontal line. So in this case, what we want to do is we want to find a point. So keep in mind that here we're finding the point as opposed to be given a point, but we want a slope, which of course is the derivative, and we want it to be equal to 0. And that will give us the points that we want. So again, horizontal tangent line, same question, but just a little bit reversed. The line is a point and a slope. The slope means I want the derivative, and then the horizontal part means I want to be 0. Keep in mind that this is not the same thing as horizontal asymptote, which unfortunately shares the word horizontal. Horizontal asymptotes are by definition the limit as x goes to infinity or negative infinity. Check out our videos on asymptotes if you want help with that. But in this case, again, even if this question is slightly more intimidating, I look for what I need. I need a tangent line, so I need a derivative. I need it to be horizontal, so I want this derivative to be 0. So why don't we just take the derivative and set it equal to 0? So in this case, what the derivative will be shouldn't be very difficult. No product rule, no chain rule required, just the power rule. So we're going to take the power, drop it to the front, of course, subtract 1. Always our favorite process, 4x cubed. Same thing here, take the 2, let it meet the minus 6. So it should be negative 12x. And then we're going to set it equal to 0 because we're trying to find the x's that make this happen. So it looks like I can take out an x and a 4. So it's going to be 4x, and then it's going to be x squared minus 3. So these are the x's that make this line have a slope of 0 because the derivative will be 0. So then I'm just going to put my answer in this box real quick. What's going to be my x's? Well, it looks like I have 0. Then it looks like I have, if you do a little bit of algebra on the side here, definitely no shame in that. X squared minus 3 equals 0. That means x squared is equal to 3. That means x is equal to plus or minus root 3. So in this case, it's going to be root 3, and x is equal to negative root 3. So what are the significance of these x's? Well, if you looked at this function and you graphed it, you would see that the function has a horizontal tangent line. And that's the significance of this. Here, same sort of process, point and slope, where the slope is the derivative. And in this case, we wanted the slope to be a very specific number, 0. We took the derivative, set it equal to 0, we solved, and we are good to go. If the question for some reason asked for the y coordinates, what you would do is you would take these 3 things, plug it into here, and you would be able to find y coordinates. I'm not going to do that because I don't feel the need for that, but perhaps that would be the question. Let's do another similar question where you select the slope to be a specific number. So I'm going to erase this right here. I'm going to erase this. So let's say we have a new function. Let's just take a nice little parabola. Should be minus x squared plus 3x minus 1. That should be sufficient for our needs. And then what we're going to do is we're going to find the x's. So again, instead of starting with an x, coming up with a tangent line, we're going to be starting with a tangent line that has a specific property. In the past one, it was that it was horizontal where the slope is 0. You'll see for this one. So find the x such that the equation of the tangent line, tangent, if I can spell the word tangent line, is parallel, I think that's how you spell parallel, to the line 4x minus 2y equals 7. So again, here we have another equation of the tangent line, but we don't start off with a point, we start off with a property of the line. So this is a nice little review of Algebra 1. We're just reviewing Algebra 1 all over the place today. What we want to do is we want to set our slope not to be 0 like the last one. We want to set our slope to be the slope of this line, because that's what it means to have a parallel line. Remember, parallel lines have the same slope. So what I want to do is I want to find the slope of this line. The easiest way, if you don't remember standard form, is just to convert it to y-intercept form, y equals mx plus b, so you can just read off the slope. So in this case, it's going to be negative 2y equals negative 4x plus 7, just bringing the 4x over. Then it's going to be y is equal to 2x, because I divide everything by 2, minus 7 halves. The 7 halves doesn't matter, that's the y-intercept. I only care about the 2x. So what's the slope here? 2. So what are we going to go for? Well, what we're going to try to do is we are going to find the x's where the derivative, because that's the calculus slope is the slope of the tangent line. We're not going to set it equal to 0 like last time, because that's when we wanted our tangent line to be horizontal. We want it to be parallel with this line, so we're going to set it equal to 2. But it's the same idea. We don't start off with the x's, we start off with a line where we want our tangent line to have slope 0. So we want our derivative to be 0. 2, not 0. So let's take the derivative. So it's going to be f prime of x. This derivative is quite lovely, nothing too crazy, just using the power rule, minus 2x plus 3. Dropping the power down, of course, the derivative of 5x is 5, the derivative of 3x is 3. Then, again, we don't plug in a number for x, we're trying to solve for x, so we're going to set it equal to the slope we want. That's going to be 2. This is going to be an easy way to find an x. So it's going to be minus 2x. Bringing this 3 over, looks like it's minus 1. Looks like our answer is going to be 1/2 as the x-coordinate of this point. And then what happens if you wanted to find the y-coordinate? Well, I don't want to do that because that's going to introduce fractions, but all you would have to do is plug it into this little guy right here. Don't plug it into the derivative, because the derivative only gives you slope values. Plug it into this to find y values, because this is the function is y values. But again, even if these equation of the tangent line questions and this intermediate difficulty seem kind of intimidating, it's the same thing. Tangent lines are all about slope. So most of the questions, you just take an x and plug it into that slope, but sometimes you're given the slope and you want to solve for an x. But they're basically the same thing. Just always take derivatives, set it equal to something or plug it into something, and you should be good to go. There is one very, very hard question on tangent lines. It's very, very rare, but we are going to do it now. And that's when the tangent line is off the curve, or the point is off the curve. So let's try that. So this is the last one. It's by far the most difficult question. So let's say we have a function, f of x is equal to x squared plus x. And what we're going to do is we're going to find the equation of the tangent line. So it's a little bit weird because we have multiple tangent lines. So find the equations of the tangent lines of f of x. And instead of using the word through a point, it's going to be using, sorry, I don't know what I'm saying. It's going to be through the point. So through the point to -3. So why is this question so much more difficult than the last questions? It's because this point is not on this curve. So if you plug in 2 here, notice that you will definitely not get -3. I think if you plug in 2, you'll get 6. So it's unlike the first few questions that we did previously, where all you needed is a point and a slope where the slope is the derivative and this point is provided. It's going to be a little bit more intimidating because we have to find the points in the first place. So you don't have to draw a picture in these questions, but the picture might help us sort of determine what's going on. So this guy right here is a parabola. It goes through the point 0, -1, I believe. So it's going to be like this. That's supposed to go across through the origin. This is supposed to be a parabola. And then this is supposed to go through the point 2, -3, 1, 2, -3. So basically, why are there 2 lines? This is how you know that this question is kind of weird. Why are there 2 lines? Why is it going through the point? It's because there's going to be a line somewhere about right here, and then there's going to be another line that's also tangent somewhere about right here, if I can make it tangent. Not my best line. Let me retry to draw this line. Be at the point 2, -3. erase my point. This picture doesn't have to be perfect. I just drew basically the same exact thing. This will eventually be tangent. Let me try to draw one more time. So I'm struggling here. This is the least important part, but I want to be consistent. So my function, and let's say it crosses the line at this point. Whatever, this is supposed to be a straight line. So basically what we're trying to do is we're trying to find these two lines, and what we need to do is we need to find these 2 points. But how we're going to do this is we're going to do a trick that happens a lot in calculus. What we're going to do is we're going to have 2 forms of the slope. We're going to have an algebra slope and calculus slope. So when we find the slope of this line, we can think of it 2 ways. We can first think of it as the calculus slope because it's tangent to this point, which is eventually what we want to find. Also, we can find the algebra slope using the algebra slope between these 2 points. And that's what we're going to do. So we're going to do calculus slope equals algebra slope. So what are going to be our 2 points? Well, for both lines, one of the points is going to be 2, -3, the one that's off the curve, and we're going to hope to find the ones that are on the curve. So this is going to be my first point, point 2, -3. The problem is that I don't know the point on this guy right here. I don't know this point. That's really what we're trying to find, but we can label it in general. Remember that every single point is x comma y, or x comma that function value. So it's going to be x comma x squared plus x. So these are going to be my 2 points. So I'm going to be able to form algebra slope, and then I'm going to try to do calculus slope as well. So again, I can find the slope of this line in 2 different ways, calculus slope or algebra slope. So I'm going to set them equal so I can find these x's. So the calculus slope, so let's write the word calculus. So the calc slope is actually a lot easier than the algebra slope because it's just a derivative, 2x plus 1 using the power rule. Then you do algebra slope. So algebra slope is going to be just our normal y2 minus y1 over x2 minus x1. So it's going to be x squared plus x minus, because it's y2 minus y1, so it's going to be plus 3. So this is minus 3 over x minus 2. So it's calculus slope equals algebra slope. And the rest of the work for a few minutes now will just be a lot of algebra stuff. Basically, I'm trying to isolate these x's. What's the best way to isolate x's when you have squares? Well, I want to factor it, but in order to factor it, I need to bring things to one side because I don't want to have fractions. And then I'm going to sort of combine everything to be set equal to 0. So it's going to be a lot of work. So let's do it slowly. Take the x minus 2, bring it to the other side as promised. It's going to be 2x plus 1 times x minus 2. Then we're going to set it equal to this thing right here. Still doesn't look like I can factor it, so I'm going to multiply this out. So it's going to be 2x squared, and that'll be plus x minus 4x as I FOIL this. So plus x minus 4x, that's minus 3x minus 2. And then still we have not done anything to the right side. But in order to factor something, you need to bring everything to one side. So I'm going to take all this, bring it to the other side. So it's going to be x squared, because I'm taking over an x squared. I'm going to take over an x, so it's minus 4x. And then finally, it's minus 5. Finally, we can factor it. So all these steps were just to factor it, because we can set it equal to 0. And then we get x minus 5, I believe, and x plus 1. Because minus 5 times 1 is -5, minus 5 plus 1 is -4. This is the correct factoring. So again, all of this algebra stuff was a lot of work. But what we're doing here is calculus slope equals algebra slope to find these points, and we finally find these points. So now it's actually as easy as all the other questions. So let's do point and slope, where slope is the derivative at least 2 more times, but it's going to be the easiest part of the work. So again, we're going to start off with x is equal to -1, because that goes with this guy, x plus 1 equals 0. X is -1. So what we're going to do is we're going to plug in -1 into our function to find the point, just like normal. -1 squared is 1. 1 plus -1 is going to be 0. Then I need a slope, but remember that slope is always the derivative when you're dealing with tangent lines. So we have 2 formulas for the slope, calculus slope and algebra slope, but the calculus slope is so much easier, so I'm going to use that one instead. Looks like it's going to be 2 times -1 plus 1, so it's -2 plus 1, which is -1. Now I'm ready to write this equation. So this one is the one that goes right here, basically. So it's going to be y minus 0 equals -1, because that's the slope, times x plus the x minus the x coordinate, which is -1. So again, At this point, I'm just doing the same exact thing, but I've done all the hard work. I've changed the hard question into an easy question. I started off with a point off the curve, which sucks. And what I had to do is I had to do all this work to find the points that are on the curve. And now that I have the points on the curve, it becomes as easy as the first question that we talked about. So finally, I have x is equal to 5. How do you find the y coordinate? Again, you plug it in. 5 squared is 25, 25 plus 5 is 30. So it looks like our point's going to be 5, 30. Our slope is going to be plugging in 5 here. 2 times 5 plus 1, that's 11. So we're going to write our line one more time in point slope form. Y minus 30 equals the slope 11 times x minus the x coordinate, which is 5. So keep in mind we have two answers here. This first answer is this line right here. The second answer is the second line that I struggled to draw in the first place. But this is the beast of the tangent line questions. This is very, very rare compared to normal tangent line questions or regular tangent line questions, so just be careful. But in these tangent line questions, with the off the curve, you just have to find the points that are on the curve to make the question as easy as possible. So you have to set up a process. Calculus slope equals algebra slope. This sort of construction will appear later on in calculus in the form of mean value theorem. But for now, you just take the calculus slope. You need to form algebra slope with 2 points. You're going to be given the off point, and then you're going to create the point that you want because it's just x minus the function. And that's how we have this point right here. Then you do algebra slope, y2 minus y1 over x2 minus x1. And then at this step, these 3 steps are all just algebra steps, bringing this x minus 2 over, foiling, then bringing all this to one side so we can factor. But once we have this, these finally become the questions from the previous, because now we have these x coordinates, where this one is 5 and this one is -1. And then once you have these x coordinates, you don't have to look at any of this except the derivative, so that you can do point and slope, where the slope is the derivative. But if this last question was a little challenging, and that's what it's intended to be, this is the beast of the tangent line questions. What you want to be very comfortable with is all the questions that we talked about in the first place. So let me just remind you, tangent lines are point and slope, where the slope is the derivative. Sometimes you plug in an x to find the slope, but sometimes you're given a property about the slope, like the slope, the tangent line is horizontal or it's parallel to a certain line. So you'll set the slope to be equal to a certain number and you'll find x coordinates. But again, if you don't get anything out of this video, just remember, for a tangent line equation, you need a point and a slope because it's a line, and the word tangent means that the slope is the derivative. If you want more practice of this question and also all the questions that we talked about previously, horizontal tangent line questions, normal line questions, and these beasts of off the curve questions, then be sure to check out our Girls Teach Calculus video. I'll link that in the description below this video. In that video, one of my former students goes over several of these examples, including 2 of these sort of beast questions at the very end. So if you want more practice, be sure to check that out. She probably explains things better than I do. Thanks again for watching. Hopefully you will understand tangent lines. Let them become your really, really good friend, because again, they're going to pop up here and there throughout your calculus journey. And anytime they show up, you want to show them a good time. But thanks again for watching, and I hope to see you next time. Thanks again.